Devavrat Shah. I'm one of the founders of Ikigai Labs, as well as the CEO. I'm also a professor of AI at MIT. I've been teaching for past 20 years. I'm going to tell you a little bit about AI. Now, instead of wearing my professor's hat, I'm going to wear a business hat and try to talk about what is the value of AI, because there's a lot of statistics, machine learning, AI that we've been doing for a long time. The question is that how can it truly sort of help bring value of AI? And as a company, as a focus of my entire academic career, been focused on what I would call structured data. Think of data that is spreadsheets changing over time, but not just spreadsheets, massive data sets living across many different data environments. And the question is that how do we use such a data that exists in every enterprise today to bring value of AI to your enterprise? Okay? And towards that, what we've done at Ikigai is we've built what I would call best-in-class AI for structured data. And today I want to talk about a few examples of how that can help do better forecasting and risk management. As a company product platform, we build a full stack AI platform around structured data, and we'll talk a little bit more about that as well. Okay? But again, I'll try to keep focus on the outcome rather than the process of how to do that. And if the outcomes are interesting, then the process, more than welcome to come to our booth. It's 437, 4 plus 3 equals to 7. Easier to remember. Great. So with that, let me get started. If you think from any business organization, enterprise's perspective, right? There are a few things that you're trying to constantly do really well. Is one, run the organization efficiently. Two, you want to grow organization in a managed risk way. Okay? If you are trying to run organization efficiently, you're trying to constantly do what I would call solve equations, balancing act. Supply, demand, cash coming in, cash going out, what sorts of people skill you need to task you want to get done. Same thing happens in sales, same thing happens in marketing, etc. So it's always balancing equations. As you try to balance these equations, parts of the equations are unknown, uncertain, and that's what you want to predict, forecast. And you want to predict, forecast that as accurately as possible. The parts that are known, you want to control, and that's what you are planning. Okay? So that's efficiency. What do you do to grow? We say, well, look, I have to take certain risk, and then here's a reward. And I want to sort of know what are the possible scenarios for risk and reward, and understand those scenario plans. Okay? So those are the two things that I want to talk a little bit more about, and how does AI can help. Okay? Before I get into details, again, this presentation, as I mentioned, is very much outcome focused for me. And best way to think about outcomes is outcomes that do exist. So here are 4 what I would call engagements that we have had over last year. So we as a company commercially launched this year, and we've had a terrific year working with very high value large enterprises. And here are the 4 examples where we started our engagement with customer, and at the end of the quarter we had things live in production and sort of successful examples. So I'll just walk to 4 examples, and there are many other things, happy to talk offline. Okay. So one on top left, here is a 2 billion plus e-tailer, retailer, manufacturer that they have been manufacturing and selling things to customers across the country. And they want to figure out whether a new product variation they should introduce or not. Okay. Well, if they do that, they have to understand what will be the demand of it, what will be its impact on other existing products, the cannibalization. Okay. Now, how would you do that? You have never sold that product before, ever. So clearly it's hard to do. What we explain to them and how to do that precisely with AI in a numbers-driven manner rather than employing an expensive McKinsey consultant who would actually put some very good spreadsheet models, is by using historical data where there is a variation in data and pattern already around similar looking products across locations when introductions happen and not. So there has been always changes happen. So there's a patterns in time and space that you can naturally learn, and from there very precisely in a quantitative manner you can say, well, this is how the distribution and uncertainty band of things would look like. This is how the impact would be on existing things. This is how the outcome on the new things would look like. And now you have effectively potential trade-off curves that tells you what is your risk and reward. And then now you can use that to make a very numbers-driven decision. They did that, put it out in the market, and we're seeing initial numbers which are very much following what we would have expected. Okay? So that's top left. On your top right, a large manufacturer manufacturing parts for airline industry. And this is where the typical cycle for your procurement process is 3 to 4 years. Okay? So if you make a decision now, it will have impact 3 to 4 years down. And so if you don't want to make a wrong decision, it's an expensive decision. And this is where you want to utilize your internal information as well as other external information that you have to bring it in to better forecast and plan those things. Okay. Going to your bottom left, this is where it's an electronic e-tailer. It's been in business for half a century now, and they've started with retail, became retail, e-tail, and they continue to thrive and do well. However, as their business has grown, they've realized that they need to be carefully manage their inventory both in their stores and their distribution centers, especially where they ship things from. This is where their cost in their inventory can get impacted heavily. Ability to very accurately forecast and then plan and do scenario analysis with that can help them a lot. And this is where they've seen reduction in overstocking and reduction in lost sales to 15 to 20%. Okay? And finally, on your top right, this is a large chemical manufacturer. The way to think about this, they got 10,000 very large customers, 5,000 SKUs. Okay, so really each customer effectively orders a new SKU. Now, of course, this SKU is formed by putting different sorts of chemical things together. Now, every time a customer orders something, they typically expect the delivery of it in 15 days. Just to get the right chemicals from the supplier, it takes them 1 month. So the question is that how do you not pay for the penalty or lose potential customer demand or not require sort of speeding up your shipment? And this is where the question was that can you start forecasting customer orders at a granular level very, very accurately? Hopefully 3 months in advance, 6 months in advance. Okay. Now, at individual customer level, forecasting is extremely hard. It's like me asking you, saying that, what days will it rain in New York in this month? Well, it rained yesterday, but if I had asked you at the beginning of December, potentially you would have been able to tell me that, well, this is the amount of total inches of rain that's going to happen in New York in December, but not which particular days. Okay? But if you put these information together across New York and across different parts of the country, then actually you can start forecasting things extremely accurately. For example, in this case, we could forecast 5 months in advance for 80% of orders with 2% error, plus or minus 1 day, because you're using information across time and space and reconciling information across hierarchies. Okay? These are just a few examples, and where no data about completely new things that you can sort of talk about. What would happen if you change certain intervention impact? having hierarchical information across time and space, using that to do better forecasts at each granularity, and then enabling experts to understand why forecast is what it is, how to help them edit it, and then sort of bring that back to reconcile your overall forecast again. Okay. That's a type of thing that sort of we try to do at Ikigai. Now, just to point out, the value of this is pretty massive. The number that sort of I would like you to focus on in that pink box, every year it seems that $1.1 trillion is lost either because overstocking or lost demand. Think of the world GDP is less than 100 trillion. So this is a pretty massive number. Okay. And then those are other sort of numbers supporting some of the different aspects of this. But really at the end of the day, this boils down to not able to run things efficiently, not able to balance equations, and not able to balance equation because not able to do better accurate forecasting, better accurate scenario analysis, what if planning. And then to do that really well, you want to identify patterns, not just in your data, but data beyond, and then bring it together. Okay. And that is at a core what we do really, really well. Okay. Just to walk you through a little bit of sort of challenges of the process like this, what I'll do is I'll take one hypothetical example or a scenario. And let's suppose that you are trying to make an important business decision. That business decision has two possibilities. Launch something in spring is coming up, or launch something in fall. Well, if you launch something in spring, you have to worry about, for this completely new thing that you're launching, what would be its demand. As you think about that, you also want to worry about its impact on things that already exist. As you think about that, you want to figure out, will you be ready to do that? Because if you're going to launch something, you want to get it into your stores. If you're getting into store, you want to line up your suppliers. You want to sort of just worry about all of those things together. If you're going to launch in fall, maybe you might be losing out on early to the market, and somebody else might sort of take up the part of the market share that you were hoping to grab. But on the other hand, it might also give you a possibility to be a little bit more risk averse. So now, effectively, what you're doing is, through your head, whether it's you're thinking from a perspective of just operational parts, or thinking from the perspective of financial parts, or thinking from the perspective of how do you think about your business as a whole, at all those three levels, you're trying to think simultaneously. Okay? And as you're trying to think simultaneously for these things, definitely as a likely in a good organization, a good executive team is coming together with a good advisory firm to sort of think through those things, and maybe then lots of great spreadsheet models will be built, and then outcomes would come out. Now, maybe that may not be the right thing to do. What you really want to do is that, yes, you want to do those processes, but have recommendations coming through a meaningful AI, okay, that are backed by your data, backed by world's data, and identifying those patterns together. So in some sense, you want to get all sorts of data out there about yourself, about your history, and about the things that you believe impact to your these decision making. Of course, you don't know, maybe if you care and you think about that, what is trending on TikTok is mattering, maybe you should, but most likely maybe not. Okay. And again, as you start thinking about just basic data sources, and here is some with certain, let's call it back of envelope hypothesis, just put some numbers together, and what's going to happen is that data points are going to start adding up drastically. Now, even if you have these many data points and you're trying to make one prediction, okay, not scenario analysis, one prediction with a modern stack of unstructured data, i.e. LLMs or things like that, and you're making a query, you're likely to pay on the order of $14,000 with previous generation of GPT XYZ model, for example. Okay? And again, this is not necessarily the full complexity. The question is that how do you use this much large amounts of data to get accurate forecast that is explainable, that's not going out to the rest of the world, and it's cost effective. Okay. And this is, if you are able to do that properly, put all the right uncertainty together, hopefully you'll come up with the following type of quotes and quotes decision tree, which will say that if you launched in spring by going through sequence of decisions, there is a 71% chance that you would be very successful, or quantified version of that. On the other end, if you put it in fall, there is a 52% chance that you will be successful. So now you got a Pareto boundary, so to speak, of your risk reward. Now you can make a decision which point, operating point, that you want to use on top of it. Now, if you want to do this really well, and again, so far I've remained very much outcome focused. Now let's start talking about a builder and engineer, as very close to me as a professor and academic. What you really, really need to do this well in less than a quarter, is a full stack of AI. If you don't have a full stack of AI, what's going to happen is that, yeah, maybe you will be able to solve it with lots of really, really bright people, but it might take you 18 to 24 months, and that's fine too. But then it will be sort of a while before you get there. So a question that you wanted to answer for coming spring, you will get an answer to that 18 to 24 months from now. The way I would think about this AI stack is you want to start with data, you will have right models on top of it, but models themselves are useless unless they are put into production, they're continuously maintained, managed, supported, observed. And these things need to be part of what I would call AI product. Again, in traditional software language, one would call it a middleware. It's an AI product which is just the right level of hooks around your models in production environment, so that when you put them together, you can empower variety of very, very high value solutions. And those are just some of the key example solution classes that I would think about that are extremely high value, sitting at the gut of every enterprise, whether it's in terms of efficiency or thinking about a growth. And at Ikigai, what we've done is we took 4+ years just to build the platform. And this year we did the commercial launch. I'm really excited about what we as a company have found in terms of traction. If anyone of you want to try to play with the platform at the AI product layer, you can just go to academy.ikigaiLabs.io and able to go and play with it. And there'll be a sort of a nice guided way so that you can actually end up building your own demand forecasting or something else. Just wanted to contrast this with the rest of the world. There's a beautiful stuff out there that's happened with unstructured data, text, image, multimodal. The primary place where we differ is the thesis in which how models in the rest of the stack is built. In the unstructured world, thinking of text and all that, since 1960s, everybody has been trying to model the language. And then 2010, people threw the towel at it and said that, I don't think we're going to do that anymore. And then sort of people went in the direction of foundation model. Well, the idea is that, well, let's take entire world's data, somehow learn, compress all the patterns out of it, effectively memorize it so that new data points come in. Now you can pattern match quotes and quotes and then extrapolate from there. Excellent way to do that. It's like, I'm sure all of us have learned multiplication as we grew up through multiplication tables. So when I would ask you, what is 16 times 9? If you remember the multiplication table, you would give the answer out of that by saying it's 144, right? Now, on the other hand, if you don't remember multiplication table, which I never, what you would do is to answer that is say, well, really, it's 16 times 10, which is 160. I know because that's how the digits work. And then I will subtract 16 out of it in my head, and I got 144. So that means that one is to memorize, and that's how you answer it. Another is to just know the algorithm, know the math. Okay? And what we've done at MIT and now at Ikigai is that for structured data, at least, we don't need to throw a towel at it. We know what is a universal functional representation that matters. So just use that to extrapolate it. And once you can do that, then compute is not required to do with GPUs. You can do all of these things with CPUs. You don't need to burn forests down. Your bills don't need to be $1 million. You can actually do a lot cheaper than that. Okay? But we can still charge you $1 million, but that's a separate story. Maybe I know that I'm, okay, 3 more minutes. So tell you a little bit about one thing and maybe one quick, let's say, a demonstration so that you can see what sorts of end outcome you can see as a business user. From a model perspective, really, one way we think about all data is a form of a very high dimensional cube. So think of this as a visual caricature. Data can come from multiple environments, doesn't matter. Doesn't need to have a same schema, lots of errors, missing values, all of that is fine. But internally, as soon as data comes to our environment from different settings, form this visual cube-like thing, which is a structure between all of them. You can fill up missing values, understand anomalies, change points, forecast, predict, do what if, saying that, hey, what if I change this thing, what the outcome would look like? What if I change a price, what will be the demand look like? But hey, what if I completely introduce a new thing? How would then my data cube start looking like? And all of those extrapolations you can do naturally, and that would take care of all of the key functionalities that are needed to bring forecasting and planning to enterprises, because forecasting and planning are fundamentally cross-functional things, and they need all of these functionalities. Okay. From a architecture caricature perspective, this is how the platform would look like. Okay, that is, connect to all sorts of things. We built hundreds of connectors out of the box. It's just a mechanical part, painful, but good engineers, so it's not complicated. But once that happens, then you want to sort of unify data. Once you have unified data, you want to predict forecasts, and then you want to scenario plan. Okay. And then sort of a layer on top, which is experts. Experts needs to understand what forecast is, i.e. being explainable, and experts need to interact with it so that they can edit it. So this has to be bi-directional, not just one directional. Okay. All right. I think I've got a minute of time. So what I'll do is I'll quickly see if I can switch and just show you something in action. Okay. So bunch of things that are there, but let me sort of show you. This is the numbers. I talked about numbers a lot. Talked about the pattern. I talked about what end outcome impact would be. But if you are in the middle of it, what sorts of reference application you might be able to build, right? Because our thesis is that AI generates right recommended actions at a different layers, so that you as an exec, you as a day-to-day analyst or a planner, you can actually consume it, understand it, and then maybe put it into practice or maybe edit it, so that the rest of the team also understands what you are doing or not. So with that perspective, what I'm going to do is I'm going to simply walk you through this end outcome, how it would look like. So this is just a reference app. At some exact level, what you might want to know is how's this year, this quarter, this half is doing, okay? And if it's not working out as per the plan that I have, what should I do? What did I do last quarter or previously when something like this happened? And what would be your system's recommendation? Now, you could call this AI agent, but really this is about AI recommendations, and agent is just a hyped up version of it. Nobody's going away. Everybody's just becoming better and smarter to use things. You also want to maybe sort of keep track of what your basic KPIs are, just a classic keeping track of numbers. Okay, you might want to just understand sort of how forecast at product level impacts forecast at revenue level, and how do those things compare? Because these are all things related, right? Every organization has a financial forecast and a sales forecast. They're always off. You want to make sure that they're all reconciled so that you know either your CFO's office is wrong or your head of sales is making a wrong forecast, or neither of both of them are wrong and they just need to reconcile. Okay. Plan, and maybe I'll just show you last thing. So those were very much exact view, but if you are doing these things day to day, these are all the operations everybody does day to day. This is why workflow tools have been around. Workflow tools have been around so that you can click, click, click and go to something. It's time that those workflow tools are first augmented with AI and maybe then sort of completely reimagined. And this would be what I would call a reimagined view of the world, where tell me what I need to do. What are my actions that I need to do? Some things do nothing, and few things you do this, and few things you do that, and why? Once I know that, then maybe I can make a decision whether these recommendations are good or not, and then decide whether I should sort of do anything with it. So now with that, I think I'm a little bit above time, so I need to stop. But if any of these things was interesting and exciting, then maybe I'll leave you with the last call for action is slide with a QR code. Okay.